Okay, so today we're going to talk about the NMEA2000 interfaces.
The National Marine Electronics Association?
Yes. The National Marine Electronics Association created a standard that allows all the gear on your boat, or the electronics gear on your boat, to talk to each other over a single bus. Now, why is that important? It's important because before NMEA2000, there were a whole bunch of different physical connections and a whole bunch of different protocols that were used to allow devices to talk to each other. And a lot of times, a Fusion piece of equipment couldn't talk to a Garmin piece of equipment, couldn't talk to a Thrain piece of equipment, for instance.
So this is like Android and Apple?
Exactly. You remember how Apple and Android, you couldn't get the units to talk to each other until we got Bluetooth. Bluetooth is a communication standard, wireless in this case, that allows all the different types of gear to talk to each other. NMEA2000 allows all this different gear to talk to each other, but it's actually hardwired. It has a set of physical connections. And that's what we need to talk about next, actually, is the different layers. Physical connections and logical connections.
Okay.
Okay, so let's talk about physical connections first. There is a standardized set of equipment, and all the standards for this gear and how it connects together is all created by the International Electronics Association, or IEC, the International Electronics Committee to be specific. And they specify all these different parts. So let's start with this one. This is just a little tap connector. So you take a tap connector and you hook a cable onto it, and again, they're all standardized. Screw the connectors together, and then you can take that and plug it into a device. I can take another tap connector and hook a cable into it and plug it into another device, and another device, and another device, until we have everything all connected together on the backbone.
Is there a limit to the number of devices you can connect?
There is a limit, but on most people's boats, you're never going to hit it because you can have hundreds of devices on there.
But we might hit it on Ray's boat.
We have a lot of stuff on Ray's boat. Okay. The other key thing here is, this is the GPS module, for instance. You can see on the bottom of it, it's got the NMEA2000 connector, but there's no power connector. The reason you don't have to have a power connector on here is because we're also going to connect power right in there, and the power cables are always a different color. So you can see that we're going to actually put 12 volts onto the backbone, and that way when you have a display unit, for instance, this is the wind speed indicator. When you have a display unit that you need to have powered, you can actually get the power right off the backbone. So that's how the GPS gets its power. So you see that everything is physically connected. One more thing I want to point out that's really important.
Okay.
You can put as many taps in as you want to, as long as you got your power in there. And there are some rules for exactly where you put your power. And if anybody's got questions about that, just shoot us an email or drop us a comment, and we will come back and answer your questions for you. But what I wanted to point out is these little connectors. These are end connectors, and you have to have one on each side.
On each end. End connectors.
Trunk. Yeah,
right.
Exactly. So they're terminators. So you actually have to terminate your trunk with these final connectors. So this is, it's a very short trunk or backbone, but it is illustrative of a complete backbone.
Okay.
Okay. Now, let's talk about what we're going to have communicate with what. In the world of NMEA2000, there are information providers and there are information users. This GPS module, for instance, which sits outside and talks to the satellites and collects your latitude and longitude. This is a data provider.
So it sends information.
Exactly. Here's a wind speed instrument that actually gives you the speed and direction of the wind. This is a data provider. It also has an NMEA2000 interface cable on it. This is a display. This is a display.
These are receivers.
These are receivers. This VHF radio, why does it need to receive? Because it gets the latitude and longitude from the GPS module, so that when you do an emergency alert, then it knows where it is.
A DSC alert.
A DSC alert, exactly. The audio system.
The Fusion audio system.
Fusion audio system. You can actually control your entire Fusion audio system from your Garmin chart plotter.
It's a big chart plotter.
You can look at wind speed, you can look at water temperature, you can look at anything you've got a sender for on your boat where you can inject information in.
So wind and depth and speed and GPS and VHF.
Well, you do connect your VHF, but only to provide latitude and longitude. You can't talk over it, and you can't send video over this interface. Another great place where you might use NMEA2000 is if you've got a laptop and you've done all your course plotting on your laptop, and you want to transfer the course from your laptop over to your auto helm.
Okay.
Then you could either control the auto helm from your laptop, or you could transfer the entire course over to the chart plotter and have the chart plotter control your auto helm. Again, all communicating over this NMEA2000 backbone.
Okay.
One of the things we haven't talked about yet is the communications protocol, or the way that the information is formatted as it's sent over the bus.
So it's sort of like an email. So it's got a header with who it's addressed to, and a subject line, and then it's got the message or the information that it's sending.
That's exactly right. The header tells you, is it going to a specific device or all devices on the network? It tells you, does it include GPS data or does it include wind speed? And then the payload, the body of the message, is the actual content, lat and long, wind speed, whatever else it is. And then if you are a multi-function device, if you want to see wind speed, it looks for packets with a header about wind speed.
And is there a limit to the amount of data that you can send from?
The packet size is limited, but you can send multiple packets.
Okay.
You would just divide your message into multiple packets and send it.
All right.
Okay. What we know then is that NMEA2000 allows all of our devices to talk together.
Okay.
Next week, we're going to talk about all the different devices that we're going to put at the helm, all the different devices we're going to put at the nav station that use NMEA2000 to talk to each other, and how we think they're all going to be laid out and organized.
And how we think they're going to work.
Now, we say we think because we believe this is how it's all going to go together. We'll do a video later on when it's all installed to see whether or not it all works the way we thought it was going to work.
It's going to, right.
Yep.
All right.
A pretty simplified explanation of how the NMEA2000 physical interface and logical interfaces work. If you do have a specific question, drop us an email at lamaroundtheworld@gmail.com, or just put a question in the comments down below and we'll reply so everybody can see them.
George will reply, because I only know what he tells me about this stuff.
Thanks for joining us.
And don't forget to subscribe.
See you next time.
Bye.